So in the last video we derived a chain rule. We showed how it worked. It's called a chain rule because when we multiply derivatives they sort of cancel out. It's going to allow us to do something called connected rate of change. But first of all, what we're going to do is we're going to practice using the chain rule. So what we do is we differentiate the inside, our g of x. Well, in this case we've got x squared. We know x squared differentiates to 2x using the power rule. So we get 2x. The outside is then differentiated. That becomes cos. We then put the original back in. So we get this. This is our dy dx. Let's now do ln of 5x. This one's really interesting. So first of all we differentiate the inside. That becomes 5. We then differentiate the outside. So that becomes 1 over. We put the original back in. So it's 5x. What you'll notice is the 5's cancel to give 1 over x. So any sort of stretch in the x direction of ln x is just going to give us 1 over x as our derivative. Really interesting. Alright, let's then have a look at this bottom one. So first of all, it's differentiate the inside. That becomes minus sine x. We showed that. We can then differentiate the outside. That becomes cos. We can put the original back in. So we've got cos of cos x. And for those wondering, this is not cos squared x. Cos squared x is just a lazy way of writing cos all squared, like this. Finally, we got a quite a complicated thing. I've also got a t, so when I differentiate, I'm going to get dy dt. So you can sort of imagine this is x to the 8. This is our function. But first of all, we differentiate the inside. That becomes 2t. We then differentiate the outside too. The 8 comes down. But it now becomes 1 plus t squared to the 7. Inputting the original back in, decreasing the power. It's a power rule in disguise. Thanks for watching, I hope this helped. In the next video we're going to derive the product rule.